finding query problems proactively with query reviews. My name is Sheeri Cabral. I'm from the Pythian group. Here's our marketing slide. We're a recognized leader in the industry. We've been having a successful growing business for more than 10 years. We've served many customers with complex requirements and infrastructure just like yours, or perhaps more complex than yours. We operate globally for 24/7, always awake services. So we do remote database management. We can supplement your DBA team, or we can be your DBA team. So these slides will be up, in fact, online probably as soon as the session is over, or rather we'll just stick them up. So query review. What is a query review? Well, it's a systematic review of all queries, right? Have you ever gone to your developers and be like, okay, basically what I want to do is look at every single query that might come out of the system, that somebody might, click something and gets a query, and I want to just do an explain and make sure it's as optimal as it can be, make sure the schema is good, make sure there's plenty of indexes. So why would you do something like that? Well, you want to find the queries before they become a problem. By the time they're in this slow query log, they're a problem. You often, you want a sample query from the developer. If a developer says, hey, this query is taking a long time, and you say, okay, tell me what the query is, and they're like, well, it's this hibernate string of objects and whatever. They can't always necessarily give you the select statement or update statement that's causing it. You kind of have to try to find it based on what you know and the function they're trying to call it from. So, who should do it? Well, the person or people that should do it are people that have optimization knowledge, right? So you can have your developers say, yeah, no, we do that, but if they don't have that optimization knowledge of, okay, let's just, if they're just adding indexes randomly because they want to do that, you have to know what the output explain means, you have to do that. So usually it's the DBA, someone with that kind of knowledge. It can be a developer with that kind of knowledge. So certainly if you're doing that, it's appropriate. Just much like if you're doing a code review, for example. So the idea of a query review comes from the idea of a code review, which is basically reviewing all of the code, or even just reviewing the changes to the code. If you're talking about a code review for a release, you're reviewing all the code there just to make sure that it's as optimal as it can be. Making sure you're not, initializing variables that don't need to be used, or allocating memory that's never used, things like that. So when and where should it be done? Well, this is a great question. Should you do it in development? Should you do it in your test/load test/staging? Sometimes those are 3 different environments. Sometimes those are 1. Sometimes they don't exist. Should you do it in production? There are arguments that can be made for all of this. Usually I would recommend doing it somewhere in the middle there, in the test/load test/staging. The reason for that is that the developers may be still working on queries, so if you end up taking, let's say, the general log from the dev machines, you might be getting too much, and you might be wasting time optimizing. Once they've already realized, oh, we're not going to do it that way, we're going to do it a different way. Production, you can say, well, A, it might be a little too late, and B, some of the tools use some memory. Like Maatkit will actually, because it has to summarize all of the log that you give it. If you give it a 1 gigabyte log, it has to use approximately a little over a gigabyte of memory. You probably don't want to be doing that in your production systems, because if you had an extra gig of memory in your production systems, you'd probably be putting it in a buffer pool somewhere. So, usually I would say here, but certainly you can also take logs from production and run tools. I'm going to specifically be talking about MK Query Digest. You can run that tool specifically anywhere as long as you have the logs. So you can run it on your desktop, you can run it on a shared machine, you can run on the developer database if you really want to. So in an ideal world, you'd have a rule that basically says no query gets put into production without having a qualified person explain it first. And basically explain it and be able to think of all the ramifications, not just of the query as it is now, but what happens when you get to have tons of data. I don't care if you do a full table scan on something with 100 rows, but if it grows to be 10 million rows, it's going to be a problem. Now, if this is going to be a metadata table that will only ever have maybe up to 100 rows, then I won't care, right? So you can't just apply these rules like, well, full table scan is always bad. Maybe it's only bad when you're talking about, having 10,000 rows, 1 million rows, 100 million rows. It should, definitely, you would love to do it before the code is released into the wild, because the idea is that it's a proactive query review, but it doesn't hurt. We'll see later, actually, that you can, the way that MK Query Digest works is it aggregates the query up. So how many people here have used mysqldumpslow or MySQL SLA or something to do a slow, to look at the log analysis? And you know how you get basically the query itself without any of the numbers and the strings? That's how MK Query Digest works. So you can actually take queries in production, let's say you have all of your query reviews on load test and staging, you can then run against a production log and see what's different, right? It will actually note that you've already, it won't give you the queries that you've already reviewed, it won't give them to you, and we'll see how that's all done. So it's actually good to do that if you can indeed manage it, because you might find that, say, for example, some actions are more popular than you planned. So maybe you're like, we don't really need to worry about this too much because this table will never go over 1,000 rows because not many people will use it, and then you find that tons of people are using it. That's one of the great things about the Web 2.0 movement, or whatever, the way that things work, is that you may think that people are going to use it one way and they use it another way, and to be really easily adaptable is a great thing. So the main tool that we're talking about is MK Query Digest. As I said, it makes what they call a query fingerprint. So you can get MK Query Digest from maatkit.org, maatkit.org. And when I say query fingerprint, what I mean is they actually make like a hash of what it is. But you know, it basically amounts to the select blah from whatever where x equals question mark or x equals string. So MK Query Digest is pretty cool. It can be used on a whole host of things. You can use it on your slow query logs. Okay, that's great. You can use it on your binary logs. This is actually pretty cool. I actually run this on binary logs. Pretty cool. One thing about binary logs and slow query logs, has time in it. It has who ran the query at what time. The binary logs also have the time, the elapsed time it ran. So if you want to say, okay, show me all queries no matter what time they take, you can actually get all the updates, right? All the insert, update, deletes that no matter what time they take, because if you have binary logs, you can just run those. So that's pretty cool. It also takes the general query logs. In MySQL 5.1, you can turn on the general query log dynamically. We've had some clients do this. They just turn it on during their mid-peak times, and then actually they tested it and said, okay, turning the query log on doesn't really slow things down for us, for our workload. Your mileage may vary. So they've actually turned it on during their peak times, and we can actually look at all the queries that happen during their peak times. So you can actually, there's more than just logs. There's more sources that you can use. You can use direct database querying. And so what that does is it uses a show full process list, connects to the database, runs a show full process list. I think it's every second or so. I haven't played with it too much. I think you can change the amount of time or when it looks. And it grabs that and it'll suck it into the report that it's doing. And then you can also use Postgres logs. You can also parse TCP dump for traffic. So if anyone's used the Poor Man's Query Profiler, it's a tool on the MySQL Forge. Basically what it is, it's you run TCP dump on a machine, and it can be a machine anywhere on the network, and it will listen and will say, okay, where I'm seeing traffic going from A to B, and I'm on machine C, and I'm seeing traffic pass by, and I'm just gonna grab those. I don't actually take the packet, I just read it. Right, so it's still going along, I'm not interfering with it at all. I'm just going to read it and store it. So you can actually parse that TCP dump for MySQL traffic. You can parse it for memcached traffic, which is pretty awesome. And you can also parse it for HTTP traffic. So again, it's not just querying what the queries are, the database queries are. You can do a lot of other things too. So you can actually get information on, okay, we put this thing to memcached, now what? Which queries went away? How many, what's the count of the queries and when they go away, and what are the new ones that are showing up as part of the memcached deep, and how often is that being used? So you can even get a real sense, not just your performance, of the database going up, but you get a really good sense of what did this actually do, because you can actually track that. So how do you get MK Query Digest? The easiest way, not necessarily the best way, the easiest way is you type wget maatkit.org/get/mkquerydigest. Basically, maatkit.org is the URL, and /get/any of the MK tools, and you'll get it. This is actually the easiest way, but they don't always keep that up to date with the current release. But again, you can do it right on the machine. It's fine. You get only the tool that you want. The repository is at code.google.com/p/maatkit. It's a little more work because you kind of have to go to the website, download it, as opposed to just wget. I guess if you know the actual release number of the thing, you can use wget to get it, or you can use links, I guess, to go in and find your way. But it's a couple of clicks. But you also get all the Maatkit tools, not just one, because you get the whole release. But it is the most up-to-date. So last week, for example, when I was touching up these slides, I just looked at it and I said, okay, well, I got the revision 6067 from wget, and the download is 6070. So that's 3 versions, and you may end up having bugs which, were fixed in the version later. So, it's up to you which one you want to use. And the other thing is that they do have very active development. So, you might want to, every month or so, go and see is there a new version out, so that you can download them. So, what's actually reported on by MK Query Digest? The default setup uses a flag called --limit, which is 95% or 20. What that means is it specifies which queries to actually show in the report. You can put in either a percentage or a number, or both separated by a colon like it is here. If you do both, it's going to pick whatever comes first. So here, it's going to show you the top 95% worst queries to show. Or the top, if you didn't have 95%, it would show the top 20 worst queries. So by default, that's what you get, the top 95 worst queries. And you can change that. You can change what makes it worse. You can, whether it's count or time or lock time. There's a whole lot of things that you can specify. So to see all queries, you can do --limit 100%, which is how I ran these. There's no -- filter by default, so this is how you can filter on other things, not just give me the top X% or top X queries. You can actually use a -- filter attribute for any attribute at this is basically documentation, part of the documentation for Maatkit. But I'll give you a sense of some of the ones you can filter on. User, right? So only show me things from a certain user. Hosts, database, process ID, lock time, memcache miss. Maybe you only want to have a report on what memcache missed, right? Rows sent, rows examined, rows affected, rows read, query time, insert ID. There's a whole bunch more. I couldn't put them all on the slide. I just handpicked a few that I thought were interesting. This tool is actually really, really useful to filter out only queries that had certain attributes. It's a very, very powerful and very, very flexible tool, and it's awesome. So, other filters, if you're using Percona's patches, and this is on that page, that web page that I showed before, you can actually filter on queries that cause file sorts or disk file sorts, right? Who doesn't want to know, okay, which query was that? You see something in your show status that says, oh, we have a lot of, sort merge passes, but which queries have them? Well, this is how you can find out if you're using the Percona patch set, or I guess it's called Percona server now. You can actually get them. You can also get which queries created temporary tables or temporary disk tables. Isn't that great? So instead of just saying, okay, we've got queries that have very large temp disk tables, let's increase max heap table size and increase temp table size. You can actually see which queries are causing this. Full table scan, full join. So which queries actually have that? Which queries actually had a query cache hit? And again, more. But I just wanted to get you a sense because I looked at this and I'm like, okay, I'm downloading Percona server. This is definitely if nothing else, even if I didn't need the performance enhancements, which by the way, we've put it on some of our clients, and without even tweaking any of the variables, it's actually more performant. Even if I didn't need that, I would do it just for these features. So, what's the output? We'll go over this in detail, but the output in general, first you get an overall summary. Then you get a detailed report of which queries match. So for each query, just kind of like mysqldumpslow, you get for each query you get a page or so. And then at the end there's a query analysis summary. And basically I've run MK. I'm going to show you examples of the output from two different runs of MK Query Digest. So hopefully you can read that. This is Perl MK Query Digest -- limit 100%, which you've already seen why we're doing that. Then -- review, which is how to do a query review, and that's what gives you the certain output, and actually gives you the output is by default, but -- review, you can see that there's a table here that we're going to go to. We're going to go to localhost port 3307. The database happens to be Maatkit. I just named it that because we use a few Maatkit tools, so we actually put in the tables that it makes into a database called Maatkit, so that we can replicate that if we need to. T is the table name equals query review. The U is the username, P is the password. That's not the exact command that I ran because don't need to give you that information. I'm glad some of you are laughing, which means you're not in complete food comas. Thank you. Then -- create review table. So this is just to make sure that it's been created or whatever. Otherwise, it'll try to insert a table that doesn't exist. -- type gen log. So this is the type of log that we're going to be parsing, and it is a general log. And it was just called genlog127.sql. And then cap that into genlogoutput.txt, because otherwise you get pages and pages and you have to scroll back and whatever. I did the same thing, same table and everything, but with a binary log. So -- type bin log, and I didn't do create review table because I knew it already existed. binlog325.sql out to binlogoutput.txt. Now one note, this binlog is something that I did MySQL binlog on the file itself. You've got this SQL thing. So you have to already convert it with MySQL binlog. You can't just give it the binary data log. You have to convert it first. Not a big deal. So I actually do suggest, if you can, using the general log for completeness sake. The binary log doesn't get everything, especially reporting queries and stuff are going to have a whole lot. If you really wanted to, you can set the slow query log to a very low threshold. You can say, okay, everything over 0.1 seconds. In 5.1, you have microseconds. If you're using the Chrome patch set, you have microseconds even in 5.0. So you can say long query time equals 0.1, and that works, and that will give you everything more than 0.1 seconds. Do 0.01 if you really wanted. So you can actually get that from the slow query log. So these are ways to get most of your queries without actually turning on the general log if that's something that you're completely morally opposed to doing. I've turned it on, it's not a big deal. So that's the other thing, is don't be afraid to turn it on and test it out. I wouldn't test it on during the peak period, but test it out during a mid-level period and see. It should probably be okay. It honestly depends on how much filing there is and all that stuff. But this was a pretty big, heavy user, client that had lots and lots of writes, and they didn't want to see any performance difference. So here's the overall summary, right? So we talked about certain parts that you find. Overall summary being the first one. And here we go. So this is the overall summary when I did the general log. Now there's a difference between the general log and the binding log, obviously, not just what commands are putting in. There's a difference in the format. But the general log, the way that it works is a query comes into MySQL and it gets logged to the general log. And then it gets parsed and executed. So you don't know how much time it took. So that's one of the reasons I did both the general log and the binary log. So that is one thing that if you're looking to see time of execution, right? So part of a query review is just go through all the queries. You don't care if it takes no time at all or if it takes 100 years to complete. You're just going to go through it and systematically review it. But usually, right, if you can do more than one thing at a time, that'd be great. So, not just doing the general log, but also doing something that shows you the time it took is usually pretty useful. So here we get the overall summary. We have 229.7 seconds user time. This is how long it took, by the way, to parse the log itself. This has nothing to do with the queries inside of it. This is how long it took. It took 860 milliseconds of system time, so if there's any context switching or whatever. And RSS and VSZ are actually, RSS is the size of resident non-swap memory. So you can see it used 100 megs here, and it used 145 megs of, this is the memory usage of the entire process, VSZ. It actually includes RSS. So basically overall, this used 145.48 megabytes. The file itself was 256 megabytes. So you can see that, if I have a 1 gig log, general log file, it might actually take a little more than half of that to do, or more. So again, you want to be careful about where you want to run this, but once you have the log file, you can copy it anywhere and run it anywhere. So as you can see here, this is just the first line of output. There's no introductory line, no welcome, thanks for using MK Query Digest. No, this MK Query Digest run was run at this point in time. It just goes right into the details. It would be nice also if it showed like, hey, this was run with this limit and this percent and all that kind of stuff, but it doesn't say that. So overall, it's It's 906. It's 906,000 total, 720 unique queries. So now we're getting to what's actually in the report. There were 906,000 total queries this actually went through, and it took 229 seconds. So it took a little less than 5 minutes to actually go through this whole log. So don't worry about it if you type your MK Query Digest command and it just sits there and sits there and sits there and sits there. It's actually doing work. Again, worry if it's on production because you might be eating up all your memory, but there you go. So yeah, for a 256 megabyte log file, it took a little under 5 minutes to process. There were 720 unique queries. That's actually pretty good. So 906,000 queries, 720 unique. It would be a real pain in the butt for me to go through 906,000 queries and be like, okay, that one I've already seen. That one I've already seen. This does it for you. 143.84 queries per second, that's the time it took to process it. So I think that's actually 229 seconds divided by 906,000. I'm not really sure. But that does have anything to do with the execution time. And it was 0 times concurrency. So here's a little graph of execution time. Total, min, max, average, 95%, standard deviation, median. It's all 0 because we have the general log. There's no times log there. So it's all 0. Probably should be like null of length, but we'll forget it. When I first did it, I'm like, is that a bug? That's not how it should look. And then I was like, oh, duh. General log doesn't have times in it. The time range, you can see, was March 12th at 10:45 to March 12th at 12:30. So in this little less than 2 hours, an hour and 45 minutes, there were 906,000 queries. That's a lot of queries. And the bytes, the file was actually 242.78 megabytes, not 256. I rounded up for fun. The minimum number of bytes in a query was 5. The maximum number of bytes in a query was 69.06K. This can be really useful for, determining the size of max allowed packet, for example. If your max allowed packet is smaller than this max, you've probably already run into problems. The average query size is 280 bytes, 281 bytes approximately. 95% of the queries were, at or less than 562 bytes, standard deviation, median, and who cares, right? That would be more interesting for the time, but again, general log doesn't have that time. So, let's see. I think that's all I have on this slide. So here's an overall summary of the binary log, which is much, much more interesting because it has some times. So again, it took 390 seconds, 1.8 seconds system time. It used about 113 megabytes of memory. Overall, 1.07 million in the binary log. This was actually over a different period of time, so a million, lots of queries. 252 unique, much easier than a million. 245.71 queries per second and 5.69 gig concurrency. So exec time, this is interesting. This actually caused me to file a bug with MySQL because notice the maximum amount of time. This is, an int, it's either the size of an int or the size of an int minus 1 kind of thing. This is actually a bug. Some of the queries happen to appear in the binary log as that size, and it didn't actually take that long. So you can see that the total is a little skewed here because of that, but it's not MK Query Digest's fault. MK Query Digest used the numbers that was in there and did the correct math, and as you can see, it doesn't run into any boundary issues with the math, right? It's doing the math properly, so it's not like it got to a large number and died because there's a buffer overflow. So the total amount of execution time is, again, skewed. Minimum execution time 0, maximum there. There was the average, which again is skewed, but that's the binary log's fault, not MK Query Digest. 95%, so this is the great thing, is that you can actually even get good information even with crappy data, right? So the data is crappy because I have some of these, but 95% of the queries were 992 milliseconds or less. So that's pretty good. Of course, that also might just mean that the bug doesn't affect most of the queries. It only affects about 5% of the queries, but there you go. And the standard deviation, the median is actually 0, which is pretty cool, actually. But that's because 992 milliseconds. So the time range, so again, this is a different time. This is from April 10th, from 7:14 to April 10th at 8:26. So this is about an hour of binary logs, but it's about a month later. So there you go, it had a million rows there. And then this is what appeared. I'm not quite sure what these all mean, add session, add session, add session, add session. But they do have this, these are times. So we have something in total time at 86 seconds. I might just do it by the username, I'm not quite sure. Minimum 0, maximum 1 second, average is 0.5. This is like 2 queries probably. 95% were done in the second, all that kind of stuff. So you can see here, here's 3.44K total, 8, 33, 20, you know, we're getting some interesting numbers here, right? You can look at time deviation, but it doesn't really matter because what you really want to find is the slowest stuff, or just systematically go through everything. And again, bytes, this actually happened to be almost 415 megabytes, so almost half a gig, and it still only took about 113 megs of memory, but you do want to be careful. And again, the minimum bytes was 5, maximum was 1.02 megabytes, the average, standard deviation. So we can actually get the average size of queries, which is kind of cool. You might not use it all that much, but it's cool to have that. So now we move on. Oh, and then error codes. There were no error codes because the binary log also has error codes in it. The general log doesn't because, for the same reason, it doesn't have slow, it doesn't have times because it's done before the query. Puts it in the general log before the query is even done. So there's no way the general log knows if there's an error or not. The binary log actually does. So there were no errors, which is pretty good. Query analysis part 1. So this is where we're talking about going through each query that comes up. You get like a little page of information. So I'm going to actually show you the same query in the general log and the binary log. So it says query 9, and that's not a typo. That's just I found the same query in the general log and binary log. It happened to be the 9th query in the general log that the 19th query that it came up with. So this is 1.69 queries per second, 0 times concurrency. So you're always going to see 0 times concurrency in the general log because there's no time information. And then this is the ID. So this is actually the fingerprint. So when you can see this stored in the database in the review table, which I'll show you later. But this is the unique identifier for that query. And you get this little thing. This item is included in report because it matches dash limit, as opposed to matching the filter, which is pretty useful. And then here's some of the actual information. So we had the percent of the queries was 1%. There were 10,000 of this query. We still don't know what it is yet. We'll actually see that at the end, which is one of the recommendations I think is put what the query is like up here. Because maybe it's an important one and I care about it. But again, if we're talking about systematically going through every query, it doesn't matter as long as it's unique. So then we have the execution time has been 0. Sweet. When I go to explain this query, it'll probably be fine. It might not be. It might be that it's a very small table now and will grow. But it's good to know when you're going to run into a query that is run a lot and has problems. Databases 1, ProgDB. I did actually remove that. It was the actual name of the database, which happens to be the name of the company, so I just changed it to ProgDB. Basically, which databases did this query use? Use 1. The time range, so when did we first see the query? It was 10:45:02, and when did we last see the query? 12:30:01 on this date. When you run this report, by the way, you'll only get it for the log you do. In the history table, or in the, not the history table, in the query review table, it will actually say, there's 2 columns, one that says the time first seen, time last seen. So if you run it again, and let's say you're running it for April data, it will actually change that. And we'll see that because that's how the general log, the binary log is actually April data as well. This is the number of bytes, again, 0% of the bytes were that. The total was 613.45K bytes for, if you add up all the bytes in the queries and all of the 10,000 queries, that's what you get. So this is a very small query, very short query, let's say. The minimum number of bytes is 59, the maximum number of bytes is 59, which means that basically no matter what values you're putting to this query, so it's either a query that doesn't have a value, like any particular value, or it's a query that has, a consistent, length of string or length of bytes in it. And especially with the standard deviation 0, you know that that's the case. Let's see. So let's look at the query analysis for the binary log for the same query. Happened to be query 5, 3.9. We're actually getting some concurrency here. It's the same ID. It's still ID 188. I didn't have you memorize it, but you can trust me on it. We'll see an example later with it. You still get this item is included in the report because it matched dash limit. Looks very similar. This happened to happen 16,829 times in the span of the binary log that we had. Exact time, anything from minimum 0 to maximum here. Here's our bug. So that we do actually know that this bug actually affects this particular query. That might be good to know when we're filing a bug report for MySQL. We say, we know it happened with this query. Again, 95% is 992 milliseconds, so it's just a bug, it's not a problem. Database is 1 prod DB, time range, so here's where we saw it. Now this binary log actually went from 714 to 826, so it actually different times there. Bytes, again, number of bytes in the query, so again here we've got minimum is 58, maximum is 59, average is 58.98. So here, maybe it's a string and a couple of ones that have one less. Maybe it's a number and there was something that had, it was like 100 versus 1,000, there was one less byte there to show. The error code, again, is nothing. So here's the part 2 of the query analysis. Note the query time distribution. There is none for the general log. So this is just kind of page 2 of that per query thing. We have review information. Here's where it was first seen. Here's where it was last seen. If we had seen this previously in the database, it would show us, it would have gotten that time to see that it was previously seen. So in fact, if you look at this March 12th, reviewed by, reviewed on comments, we'll see how to update those later. But right now, since this was the first run, as you saw when I did -- create review table, there is nothing. However, if you do run a report, you will be able to see that information. So it is kind of nice if you want to say, okay, show me all the queries I have reviewed, you can do that. So here's the same query part 2 for the binary log. And if you see here, this query analysis time distribution actually filled in. This is what it looks like. You kind of get this railroad track of, it's like a sidebar graph to see what's the distribution. So you can see pretty much a lot of the time it was 1 second or less, or rather on the order of magnitude of 1 second, right? It wasn't on the order of magnitude of 100 milliseconds. Remember the standard, 95% of the time, the query was 992 milliseconds, which is just about a second. So what you really want is, everything to be here, 1 millisecond over here, or was that microsecond or millisecond? Microsecond, because MS is millisecond, US is microsecond. It's, I guess it's the textual way to say view. So review information, here you can see now, remember we ran this again, it was March 12th at 10:45 that we first saw it. That's what happened last one, right? Doesn't change, but now last seen is now here. So we've added now to the information in the database by running this, right? So even though in the log it should say first seen 4:10 at 7:14 a.m., because the entry was, this fingerprint was already in the database table that we put, it's giving us the report that, hey, you've seen this query before. And again, no reviewed on, reviewed by comments. So here's the third part. And I believe this is the last part. Yeah, this is finally we'll get to some of the information we really want. Here's the query, here's the tables used, okay? And so this is actually a neat feature of MK Query Digest. It shows you not just what table you used, colors and prod DB, it gives you this information. You might want to know show table stats when you're running an explain. You might want to know show create table, right? Because if you run an explain, you might say, okay, why isn't it not using any indexes? Well, maybe there are no indexes on that table. So it's commenting it out, but it's giving you this information. Here's the actual query itself with a sample, right? Update color set publishable flag equal to true where ID equals a number. So again, we can see, remember we said that the length of the query is pretty constant. Here's why. Because nothing changes except for this number at the end, and it's probably always an int. So it's, now they have converted for explain. So this is an update. You can't explain an update. You can explain a select. So you can see here, select publishable flag equals true from colors where ID equals 267354. I wouldn't have publishable flag equals true. I would actually say select publishable flag from colors where ID equals 267354. But this is an automated program, so it's pretty darn close, I'd say, for not having to do anything, not having to think about it myself. That's not bad. So from the binary log, we basically get the same thing, converted for explain, and there we go. So now we can talk about this is the query analysis. Oh, so let's look at the query again. Now that we have the context of update color set publishable flag is true where ID equals this number. You can see, number of bytes. Yeah, it's going to stay pretty constant because it's only the length of this number that might change, right? It's only if this number is 1 byte, 2 bytes, 4 bytes. It happens 16,000 times here. The seconds, yeah, we can see this shouldn't take seconds. If something that's ID, I bet that there's an index on it, right? When I do an explain, I would see that in fact there is an auto increment ID on this primary key. So yeah, we could say it shouldn't take too long to find one ID, right? One flag where an ID is this, or to update one flag where the ID is that, and that's why it's actually, if it was a select, it would take much quicker amount of time, but you're actually updating it, so it takes a little longer than a select would. So there you go. So now let's look at the query analysis summary. So now the query analysis summary, I only have this for one of them. It's 5, so this is from the binary log, but they look the same for the binary log and the general log. So what you have is you have the number profile. So this is the profile. This is supposed to be the section header right here. This profile. So you have the rank, the query ID, the response time, the number of calls, the response per call items. So basically, query number 1. So here's query number 5. This is the fingerprint. This is the response time. That's the average. So it's 5.2% of the response time was because of this. So we might really be interested in this one, right? 39%, 0.8% of the response time was that. And this is actually, you can see how it sorts. Right, so what's query number 1? It's the one with the longest response time. Number of calls, right? So obviously number 2 had more calls than number 1. The number 1 was, took more time on average. So this is the number of calls, and then you get this number, and you see where it says update colors. Here it says update SKUs, insert user events live, begin, update offers. That's all you get of it, but it's really cool to get that summary of like, okay, you can see that. Maybe you end up seeing update colors, select colors, delete colors, insert colors, and like, oh, we're really overusing this table. Let's do something about that. Maybe we can move the selects off to a slave. Maybe we can do something else. So I showed you all of that because A, you can get that output from there, and that's what you get by default. I'll show you how to not get it at all. But that can be useful for other things, not just a query review. And basically, now we can look at this query review table, and I don't have to explain anything because I've already explained it all. So basically, remember we did that command. What does a query review table look like? I'm glad you asked. It looks like this. This is just one particular thing. Notice our checksum. That happens to be our update color, set publish equal flag equals true, or ID equals whatever. So we have a question mark here. That's the fingerprint. The sample itself is 100563. The checksum. Note that the checksum itself is this OX. It's a number in hex. And I just copied it right from the report, right from this thing here. I just copied and pasted this. And the checksum is actually a number. I have no idea why they need a hex number instead of a regular number, but it doesn't really matter because you get it back out. But just, if you're kind of doing a report, you might say, why is it, I want to find that, why is it giving me a number instead of a hex number? It's all a number underneath. First seen, March 12th at 10:45, last seen, April 10th, so it's storing that in the database. It wasn't reviewed by anyone, there were no comments. So these are just fields in the database. You could say reviewed by Sheeri, reviewed on a certain date and time, and you say comments, this query is really good. It uses the appropriate index, whatever you want to say. You could say the developer who wrote this should be shot, whatever you want. Or you might want to not have it reviewed until you're done reviewing it. You might say in progress. And because you have this in the database, you can actually come up with your own kind of code. So maybe you have something that's reviewed by a certain date, reviewed on a certain date, and then your comment can say needs more work, right? So then you can select everything in the database that says needs more work. So, how do you review a query? Well, use explain and show create table. That's probably another session somewhere at the conference on actually how do you do it, how do you optimize a query, all that kind of stuff. But once you do that, right, now what? Well, now you do an update query review, set reviewed by equal to Sheeri, reviewed on equal to now, comments this query is okay, it uses the primary key to search on. Which is what it does, right? Update, goes everywhere, checksum equals that. And I use the number just because. Is a query okay? One row affected. So one query down, and 769 to go. But this is why it's a systematic review, because you can do maybe do 5 of these per day, right? And it doesn't matter, and even if they do a new release, right? So if you ask the developers, let's say the developers have a list of all the queries they did, and they give you this list, right? You ask a month later, they're going to give you the whole list again. They're not going to give you only what they changed. I mean, if they do, then I'll happily work in your company. But very few people are in that kind of a situation, right? It's usually like, well, we don't know what queries they run, and I guess we can turn debugging on, and that might give you the queries, but even if you could get that, it wouldn't be aggregated like this, where, you can run a query review, and after your release, you can run another query review. You can say, you didn't tell me about this query, So imagine that this was, reviewed on as null, and reviewed on, has 0, and then you do a release, and it says reviewed on equals 1, and you're like, oh, you put a new query in there. Nice to know, especially, look, I do remote database management for several clients, probably about a dozen clients, right? So I'm not intimately familiar with exactly how everything works all the time. So being able to do this, I can say, hey, did you just do a code release? If something broke, or something is taking a lot longer now, at their normal peak time, and they can say, wow, something's a lot longer. I can say, you know what, you added this query, and it's not optimized. So again, it's already a problem, but it's a whole lot easier to pinpoint what happened, because they don't always, at least my clients, some clients, have us intimately involved with the release. Some clients, are just like, hey, there's every other Thursday, and we have downtime, and they won't necessarily tell us what new queries they're adding. And then things break, and they're like, well, why is it slow? We can't just come back and say, well, what did you do? Right? It's our job to figure out what's causing the slowness. So, 769 to go. It's a systematic approach. So, I already said this, we look at a few queries per day. Reviewed queries do not appear in subsequent reports of MK Query Digest. So you know how we had the report, and we had the analysis, and then the middle part, where it gave us a detailed report of each query. By default, that won't show up when you've already done that. So this is query number 5. By default, then I would get query 1, 2, 3, and then 6. It wouldn't actually show that in the detailed report, which is useful because if you do want that output, you probably don't want it for things you've already reviewed. You can actually that's only if you have something reviewed by. So reviewed by was in a text field. So if you really wanted to, you could always print out the report by never saying who reviewed it. Right, you don't fill in the reviewed by column, you only fill in reviewed on, and maybe you put who reviewed it in the comments. Right, and that way you can almost have okay, when was the last time this query was reviewed? Let's do it again. And that will show up in the report. Because that's the interesting thing, is that it looks like this, right? So in the report itself, you'll see the query and it'll show you the reviewed on comments, even if the reviewed by is on. So, let me get back here. Unless you specify --report -all. So if you specify report all, by default, actually, the --report flag is set. So if you specify --report all, it'll say, show me everything, even if I have reviewed it. So, --no report will just parse the log to the database, and you'll get no output, right? So we got output, I showed you that whole thing, but if you just want to say, okay, here's a new log file for you, maybe you'll automate that. It just parses that log to that database, and you're done. Let's see how we are for time. Getting close, huh? So, here's this --no report. Type bin log, my bin log of text. It can save counts, etc., to a historical table. And here's how we do that. Here's the normal thing: limit 100%, no report, review. Here's the DSN of the review, basically how to connect to that. Here's the new part to do a historical table. Because it's the first time, it's create review history table, review query history. Here's another DSN for where to put this history table. So if you really want to, you can put your report table and your history table somewhere else, on different places. I happen to put it in the same database, different table names, same user password, type genlog, my genlog text. So what does the query review history table look like? So here's the same query, checksum equals whatever. So we've got a sample here, that's good. Minimum, maximum timestamps that we saw it. Again, I only did this. This was only done with the general log here. So you only see it with this April date. Count 16,829. We saw that. Query time sum. So the total amount of query time. So this count will this won't be updated on subsequent ones. You will actually get another row for it. So then you can say, okay, select star from QR history where checksum equals this. Once you have more rows, you'll get 2 rows. A lot of these are null, lock time sum, lock time in, lock time max. That's only because this particular one didn't have that. An update doesn't send any rows back. An update doesn't necessarily, I don't know if it doesn't examine rows. I guess it must examine rows, but that might be because I don't have done on the Corona patch box. And I think Rose exam is only that. Or it might only be because that's what's in the slow query log, and I can do it in the slow query log. So, I know I'm running out of time here. Query time percent, whatever, so we do that. Here's what happens when we have 2 rows, right? So if we do this on the March log 2, here's what we get. So it can be kind of nice to see, okay, let's compare different runs of it, and what maybe you have an average time at different runs. So, we're almost done. Here's what I like to see besides query reviews being common practice. I'd like to see more fields in the query review table, like which index was used, and tables involved in their approximate row count, approximate rows examined from explain, which again you might get in the slow query log. More fields in the query review history table, like the source, this was from a gen log or a bin log, when the review was done. So start today, grab a log, find a test machine or database, explain all your queries, and look at MK Query Digest because it has tons of other features that I haven't even gone into here. Thank you very much. If you want to, I have I wrote a book. It's pretty good. You can win a signed copy. Basically, we want to put you on our email list, which is kind of actually brand new. You can always get off the list. You just basically give me your business card. I'll do a drawing right now, very quickly. And that's about it. And thank you very much. And that's it.